LandXML is a great file format for sharing spatial information on earthworks and corridor projects. And the reason it is such a great format for that is because it's recognized by many different software packages and it's usable on many different pieces of survey equipment. Now, a LandXML file can contain points, lines, alignments, tins, and cross sections. So seeing as that it's so recognized by many different software, if I want to take an alignment that was started in Civil 3D and use that in RoadEng, well, I'll use a LandXML file to transfer that information. Or perhaps my surveyor has created a tin and he wants to share that tin with me and he wants to preserve the triangle faces of what he's created. Well, sharing that as a LandXML is a great way to do that. Now what module I use to import my LandXML information will depend on what I want to use. So if I have point, line, or tin information that I'd like to bring in, I'm going to bring that into the train module. Whereas if I have alignment or cross-section information that I'd like to use, I'll bring that into the location module. So let's start by bringing point and tin information into the train module. So we'll open train. We'll click Insert File. And in this drop-down, we can see that if there were multiple surfaces here, we could select the one we'd like. And we can see the points from that LandXML file are displayed. And we'll click the 3D view and we can see the surface associated with that. So if the LandXML file has tin information defined in it, we don't have to model the tin. It's already created. Now let's turn off our points just to slide our data so each point doesn't represent a lot of information here. And let's create contours. So we'll click Train Modeling and we'll turn off Calculate Triangles option. And that's because we don't want to redo the tin, we want to preserve what was sent to us, and there we are. Now that was an original ground example, but we can do the same thing with design surfaces. So let's open a new instance of train. We'll click Insert File, and here let's select our realignment design. So we'll bring that in, and we can see in this case we have multiple surfaces to pull from. We'll display this one, and we can once again see the tin surface associated with that. So let's switch over to location. We'll bring in an alignment. So we'll start by clicking New File, and we have the option to reference a LandXML file for our topo surface instead of a train file if we'd like. So we'll do that in this case. Then we are going to set our alignment to be based off of a LandXML file. So here we've got both a horizontal and vertical alignment defined in that LandXML file. We'll click Next. And we could create cross sections based off of the sections in the LandXML file, but to start I'm just going to use the default setting. So since we've used the default cross section setting, we have our default cross section template applied. So with that, it has smarts in it. So if we move it up and down, it's going to react accordingly. Now, if we go back and we go through that process again, but if we set our cross-section geometry to be based off of the cross-section geometry in the LandXML, then we get fixed cross-sections. So with that, they're going to not be dynamic, where if you shift your alignment up and down, it's not going to adjust accordingly. Now, fixed cross-sections are a useful tool and most commonly used for as-built or to get material takeoff estimates. So for more information on that, you can refer to our resources on fixed cross-sections or as-built workflows.